Hello everyone, myself Ratna Gatki. I hope you all are safe at home. Children, in last class we discussed about compounds. Recapitulation: compounds, chemical formula of compounds, valency, ions, radicals. In today's class we will discuss about how to write chemical formulae and chemical equation.
Before writing chemical formulae, we came to know about cation and anion part. Here we are taking the example hydrogen chloride. In this, which is the cation part and which is the anion part, first we came to know. Hydrogen is a cation part or electropositive element or basic radical. Here chloride is anion part or electronegative element or acidic radical. Chemical formula between monovalent electropositive and monovalent electronegative element. Some monovalent electropositive elements are there in this chart. We will see these elements: hydrogen H+, lithium Li+, sodium Na+, potassium K+, ammonium NH4+. Some more examples are there here: silver, gold, copper, mercury. Monovalent electronegative elements are there in this chart. Fluoride F-, chloride Cl-, bromide Br-, iodide I-, hydride H-, hydroxide OH-, nitrite NO2-, nitrate NO3-, chloride ClO2-, chlorate ClO3-, hypochlorite Cl. These both monovalent electropositive and electronegative elements have valency 1. Now we will write chemical formula for monovalent electropositive and electronegative element. First, we will take an example: hydrogen chloride. We know the formula of hydrogen, that is H. Chloride Cl-, H+ and Cl-. Now we will write chemical formula between monovalent electropositive and monovalent electronegative elements by taking an example. First, we will take hydrogen chloride. First, we have to write the symbols of an element that are combining. Here, symbol of hydrogen is H and chloride is Cl, which has valency +1, chlorine valency -1. Cross over the valencies of element and write the number at the base of each symbol. Here H+ means it has 1 valency. Cl has -1 valency. We have to write like this. Now we can combine this one by writing like this: HCl. Here this subscript, if 1 is there, here we should avoid writing this 1. Now it will become HCl. Now we will take another example, that is hydrogen bromide. As we know, the symbol of hydrogen is H+, bromide is Br-. Here the valency will be +1 for H and -1 for Br. Now we will write these valencies like this: -1 +1. Now it will be HBr. Here 1 is there, so we are avoiding writing this 1 here. Then it will become HBr, hydrogen bromide. One more example we will write here: sodium chloride. formula of sodium is Na plus, whereas chlorine is Cl minus. The valency of sodium is 1 plus and chlorine is 1 minus. Minus 1 plus 1. Now we will write the formula like NaCl, which is the sodium chloride. Here 1 is there, that's why we are avoiding. Right now, by comparing these two charts, we can understand few more examples. Hydrogen reacts with fluorine, hydrogen fluoride, hydrogen chloride, hydrogen bromide, hydrogen iodide, hydrogen hydride. Lithium fluoride, lithium chloride, lithium bromide, lithium iodide, lithium hydride. Next, sodium. Sodium fluoride, sodium chloride, sodium bromide, sodium iodide, sodium hydride. Next, potassium. Potassium fluoride, potassium chloride, potassium bromide, potassium iodide, potassium hydride. Next, ammonium. Ammonium fluoride, ammonium chloride, ammonium bromide, ammonium iodide and ammonium hydride. Like this, we have to write the formula of a monovalent electropositive and monovalent electronegative, which has the valency 1. Now we will discuss about chemical formula between valency 1 and 2. Here some charts will be there. As you know, monovalent electropositive element which has valency 1 will be hydrogen, lithium, sodium, potassium and ammonium. This chart has divalent electronegative elements which has valency 2. We will write the formula for valency 1 and valency 2, means monovalent electropositive to divalent electronegative elements. Example, hydrogen oxide, hydrogen peroxide, hydrogen sulfide, hydrogen sulfate, hydrogen sulfide, hydrogen carbonate. Now let us start writing chemical formula for these. Sodium and oxide. Formula for sodium is Na. Oxide, as you know in the table, it is O minus 2. O valency minus 2. Sodium plus 1. Now we will exchange the number of valencies like this. 2 like this, 1 we will write like this. Now Na become 2, O will be 1. Now formula for sodium oxide is Na2O. Next we will move upon hydrogen peroxide. Formula for hydrogen will be H plus, whereas peroxide O2 minus 2. Here again we will write like this. Minus 2, this one will be 1. Now H2O2, we have to write this one in bracket. Now it will become H2O2. Next, sodium sulfide. Formula for sodium will be Na plus. What about sulfide? Here it is there. Sulfide S2 minus. S2 minus. Again we will exchange the valencies. Here this is minus 2, this will be 1. Now we will write the formula like this. Na2S, that is become sodium sulfide. Next, potassium sulfate. Formula for potassium will be K plus. Sulfate SO4 minus 2. Now again we will exchange the valencies for this also. K1 SO4 minus 2. Thus, we can write like this, K2SO4. Potassium sulfate. Next, potassium dichromate. Formula for potassium is K. What about the dichromate? Here it is there. Dichromate Cr2O7 minus 2. K plus Cr2O7 2 minus or minus 2. Again here we will exchange the valencies 2 and 1. We can write the formula like this, K2Cr2O7. Directly we can write K2Cr2O7. Next, copper carbonate. We know about the formula of copper, that is Cu plus. What about carbonate? Yes, CO3 minus 2 or 2 minus. Now again we will exchange these valencies and we can write the formula like this. CuCO3 is the formula for copper carbonate. Like this, we have to write the chemical formulae for monovalent and divalent.
Now we will discuss about chemical equation. Before that, let us see what happens in a chemical reaction. Two products react with each other to form new products. To understand this process in a simple way, we can say that A plus B react with each other to give C and D. Two substances A and B reacted to give new substance C and D. So this is a chemical equation. Now, definition of chemical equation. The representation of a chemical reaction using symbols and formulae of a substance is called chemical equation. There are two sides in a chemical equation, right and left. On the left, we have substances which undergo a chemical change are called reactants, and the new substance is formed as a result of chemical change are called products. Reactants react to form products. A plus B react to give C plus D. The arrow shown is the direction of chemical reaction. A and B react to give C and D. If any condition is applied, like heat, it will be written as heat on the above the arrow. A and B react after heat was applied. For example, hydrogen reacts with oxygen to give us water, as it's a chemical change. It implies that chemical reaction took place. Using words, we can represent the chemical equation like this. Hydrogen plus oxygen gives rise to water. That is, H2 plus O2 gives rise to H2O. Look at the equation. On the left, there are two atoms of oxygen, and on the right is one. Where did another one go? Is this equation correct? Yes, the equation is correct, but it is unbalanced. Now let us discuss about balanced and unbalanced chemical equations. While writing a chemical equation, count the number of atoms of the elements in both the sides. The number of atoms of each element should be the same on either side of the equation. By taking example, we will discuss about this. H2 plus O2 gives rise to H2O. This is the first equation. Now, second equation, Zn plus H2SO4 gives rise to ZnSO4 plus H2. Zinc reacts with sulfuric acid, gives rise to zinc sulfate and hydrogen. Now let us draw table under the first equation. In first column, we have to write elements. In second column, we have to write number of atoms in reactants. In third column, we have to write number of atoms in product side. Which are the elements involved in the first equation? Yes, just two elements. Which are those two elements? Yes, hydrogen and oxygen in the first column. Now, for each of these elements, we need to find the number of atoms. On the reactant side, number of atoms of hydrogen is 2 and the number of atoms of oxygen is also 2. Now, we look at the right hand side which has the product. How many atoms of hydrogen exist in the product? 2 hydrogen atoms. And how many oxygen atoms are present in product side? Just 1. For each element, we look at the numbers written in the second and third column. For hydrogen, we see that the number of atoms on each side is equal. But for oxygen, we see that the number of atoms on left side is 2 and that on right side is 1. Do you know what we can call such an equation? Yes, unbalanced chemical equation. If the number of atoms of each element on the reactant side is not equal, the number of atoms present in the product side is called unbalanced chemical equation. Now, can you make similar table for equation 2? Yes. Now, we will fill the values in the table 2. We have elements like zinc, hydrogen, sulfur and oxygen. Now we will fill these in and column. Zinc, Zn, H, hydrogen, S, sulfur, O, oxygen. Now, number of zinc atoms in reactant side is 1, as well as in product also 1. The number of hydrogen in both the side will be 2. Number of sulfur in both the side will be 1. The number of oxygen in both the side will be 4. Now, the number of atoms in reactant side is equal to the number of atoms in the product side. So, this equation which has same element, number of elements in both reactants as well as product side is called balanced chemical equation. Balancing the chemical equations. Hydrogen reacts with oxygen to form water. H2 plus O2 gives rise to H2O. This chemical equation is unbalanced. The number of oxygen atoms on the left is not equal to the number of oxygen atoms on the right. Now, question arises. Can we balance this equation? The answer is yes. Let us go step by step and see how can we balance it. In the first step, always draw the boxes around each element or compounds like this. Why did we draw these boxes? Because nothing in the boxes can be changed or altered when we are balancing the equations. Next, we form a table like we already drawn here. This row in the table tells us that the number of atoms of oxygen on the reactant side is not equal to that on the product side. It's 2 on the left and 1 on the right. So, let us try balancing the oxygen atom first. As there is 1 oxygen atom on the right and 2 on the left, we multiply H2O with 2. What we have here is partially balanced equation. The number of oxygen atoms on the right is 2 and there on the left is also 2. Remember, we can't alter the formula of a compounds or elements involved in the reaction, which means that balancing the oxygen atoms, we can't write H2O2 because it is incorrect. Let us go back to the partially balanced equation. The number of oxygen atoms on each side is equal or balanced now. But what about hydrogen? When we multiplied this compound by 2, the number of oxygen atoms here will be balanced in each side. But what about the hydrogen atom? The number of hydrogen atoms became 4 on right side. And what is the number of hydrogen atoms on the left? It's 2. So, how do you think we can balance the hydrogen atom now? We can multiply the hydrogen on left side with 2 to get this. Is the equation balanced now? Absolutely. We can confirm this from the table and verify it. This is what will you get. So, we multiply with appropriate elements or compounds as necessary to balance each and every element. When all elements are balanced, we can say it is the balanced chemical equation. Children, by this we finished our first chapter, Elements, Compounds and Chemical Formulae. In detail, we will study in higher classes. Complete your worksheet. Thank you for watching.